Welcome to our Arduino project number 7. In this project, we are going to perform and build a temperature alarm in Arduino. A temperature alarm monitors the temperature and triggers an alert when it goes above or below a set threshold. It's beneficial for various applications, like home temperature control, greenhouse management, or equipment safety. For this project, we will need different Arduino materials. First, we need a DF Arduino Uno. This will be our main board. Next, our prototype shield and a LM35 temperature sensor. We are also going to need a buzzer, male-to-male jumper cables, a USB 2.0 to Type of B cable, and a breadboard to assemble the project. Let's start by merging the prototype shield and the Arduino board. This will make it easier for us to build and connect other materials to the board's components. Next, bring out the breadboard and the LM35 temperature sensor. Pick 3 slots from the board and place the sensor on it. Next, get the buzzer and place it a few slots away from the sensor. After this, we will be needing the male-to-male jumper cables to connect the sensor to the Arduino board. Bring one of the cables out and connect one of its other sides to the left end of the sensor and connect the other side to the GND of the Arduino. Bring another cable and connect one of its sides to the center of the sensor and connect its other side to the analog pin number 0. Next, bring out another cable and connect one of its sides to the final slot of where the sensor was put and connect its other side to one of the 5-volt slots in the Arduino board. Let's move on and connect the buzzer to the Arduino board as well. Let's start by putting one of the cable's ends on the negative slot of the buzzer, and its other end on the digital pin number 3 on the Arduino board. And lastly, bring out the final cable and put one of its ends on the positive slot of the buzzer, and its other end to one of the Arduino board's GND slots. And finally, we can now bring out the USB 2.0 to Type of B cable and connect our Arduino to our PC.
Variable declaration float temp. Variable will store the temperature value as a floating point number, and the INT temp pin equals 0 semicolon defines the analog pin where the temperature sensor is connected, and the cons INT buzzer equals 9 semicolon defines the digital pin where a buzzer is connected. This is the setup function for the board setup. Serial begin 9000, open and close parentheses 9600. Initialize a serial communication at a bandwidth of 9600. This allows us to send data from the Arduino to a connected computer for monitoring and debugging via the serial monitor. The loop function for the void loop, temp equals analog read over parentheses temp pin. This line reads the analog voltage from the temperature sensor connected to temp pin and store it in the temp variable. The value is read between 0 and 1023. The temp pin equals temp times 0.8828125. This line converts the analog voltage to the temperature in degrees Celsius. The specific conversion factor 0.4882825 depends on the characteristic of the sensor and the voltage to temperature relationship. Conversion factor must be adjusted based on your sensor datasheet. And if in open close parentheses temp greater than 25, tone buzzer 1000. This conditional statement checks if the temperature is greater than 25 degrees Celsius. If the temperature exceeds 25 degrees Celsius, it triggers the tone function, which generates the 1000 Hz tone on the buzzer connected to the pin 9. This can be used as an alarm or alert when the temperature threshold is exceeded. And the serial print temperature is equal. This starts printing the text to the serial monitor. And the serial.print temp, this prints the temperature value stored in the temp variable to the serial monitor. The serial.print or the time C, this prints to indicate that the temperature is in degrees Celsius. And lastly, the print serial print in adds a new line character to separate the subsequent temperature readings in the serial monitor. And the delay 1000, delay is the process the loop for 1 second or 1000 milliseconds before reading the temperature again. And this effectively updates the sensor reading every seconds.